Another quick video, just doing an indirect truth table for the valid form and invalid forms, or a couple examples for pure hypothetical syllogism. So again, we've already laid out the valid and invalid forms for the three types of fundamental forms. But I'm just doing a couple videos with indirect truth tables so we can see how how each of the forms are in fact valid or invalid. So just to go through the indirect truth table for the valid form, again, if P then Q, if Q then R, and then your conclusion, if P then R, Q is acting as the middleman here. Pure hypothetical syllogism, every statement in the syllogism is a conditional. All right, so first thing, let's highlight the main operators, which is going to be the conditional in each of these statements. We want all true premises and a false conclusion. So let's start with the false conditional, because whenever there's a false conditional, you're forced into true antecedent, false consequent. So R is going to be false here. This conditional is true. If the consequent is false, you're forced into a false antecedent, because if it was true, then the conditional would be false, and we've already stated that. So let's see, let's fill in what we've got. Q is false. Again, we've got a true conditional with a false consequent, so the antecedent is going to have to be false, or else the conditional would be false, and that would be a contradiction. But we have a contradiction here anyway, because we have true P, false P. Those don't match up, so we weren't able to complete the line that would make the argument invalid. Therefore, this argument is valid. Let's move on to the invalid forms. So pure hypothetical, there's I don't know exactly how many combinations of invalid forms there are, but I put up a couple of key invalid forms. Let's see, this one has the second premise reversed. So just a reminder, when you're looking for the valid form, Q acts as that middleman. So it's going to be the antecedent in one of the premises, consequent in the other premises, in the other premise, and then the two are going to remain. P is going to remain antecedent in the conclusion. R is going to remain a consequent in the conclusion. So this one we flipped around one of the premises. This one we flipped around the conclusion. So if P then Q, if Q then R are the same, but the conclusion is reversed. So those are two of the common invalid forms. So let's go through and do an indirect truth table for each one of those. Start. All of these, we're going to have the conditional as the main operator. True, true, false. Start with the false conditional. You're forced into having a true antecedent and a false conclusion, or a false consequent. So already we know that P is true. We know that R is true. So let's look at each statement. We're not, actually, yeah. So Q has to be true there. So if it wasn't, then the conditional would be false, and we've already stated that. So that statement looks good. Conclusion looks good. We've already filled it in, so let's look at the second premise. True conditional. We have a true antecedent. Q, we already know from the first premise that Q is true. Looks like there's no contradiction there, so we're good. So since we found a line with all true premises and a false conclusion, then we know that that argument is invalid. Let's look at the last one. So we have true, true, false. Start with the false conditional. we're forced into a true antecedent and a false consequent. So we fill in what we have. R is true, P is false. That one I'll come back to. Let's start with this one. True conditional. We have a, actually, which one? False. Actually, actually we have two possibilities here. So we have false, true. Let's bring down true, 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 false, false. We have two possibilities for Q. So we'll fill in those two. First one is true. Second possibility is that Q is false. So let's see if there's any contradictions. Oh, filled that in wrong. So true antecedent, false consequent. We have a false conclusion. Both those are true. Both those are good. True, true, true conditional. That's good. False, true, true conditional. Those are both good. And then false, true, true conditional. That's good. False, true conditional. That's good. So we actually filled out two lines, but we only needed one. So this argument as well is invalid.